So the first thing we're going to do, we're going to understand that this is an abacus. This abacus is a learning tool. This learning tool helps me count. So we're going to add, subtract, multiply, and divide. So what we're doing is we're understanding that this is 1. So notice that what we're doing is when none of the beads are touching this horizontal bar, this is what's considered 1. I'm sorry, 0. So because we have 0, and then we have 1. 1 looks like that. And then 2 looks like this. What are we doing? We're counting on the abacus. So I'm just showing how it looks like on the abacus. So when we do 2, right, we do 2, we have 1, 2. That's what 2 looks like, just like that, number 2. And then we have 3. 3 on the abacus looks like that. And then 4, well, that's 3. We have to make sure that all the beads are touching, so that's 3. And then we have 4. This is 4. And then after 4, we have 5. Notice what we're doing is we're just learning how to read the abacus. So we have 5. The top bead will always be 5. The top bead will always be 5 because it's always 5. This is it, right? The top bead is always 5. But when we look, this is not 10. This is 55 because the top bead is always 5. So then we have 6. If I have 6, I have all of these numbers. These are all 5s. And then I have 7. Oh, wait. So this is 6. And if I do this, then these are all 6. If I have 7, and then if I make these all 7s, notice that the beads are touching the horizontal bar. When the beads are touching the horizontal bar, that's what's being counted. So we have 7, and then there's 8. 8, right, is 1 bead on top and 3 beads on the bottom. Thank you so much for the likes. Okay, so we have 8. Why are we doing this? Well, we want to learn how to read the abacus. After we learn how to read the abacus, we will do some adding and subtracting. Hello, not so pro. Thank you so much. Welcome back. Welcome back. And then we have 8, right? But these are all 7s. So this is actually 6, but this is 7. So I'm going to make them all 8s. So this is now all 8s. And then we have 9. 9 looks like that. 9. These are not 9. This is all 8. 8. These are 8, right? But this is 9. So what I'm trying to do is I'm trying to show the contrast between these numbers and these numbers. This is 9, so when I put them all together like that, now we have 9. 9, 9, 9, or 9. This is 8, so we do 9, and then 9, and then 9. Cool? Yeah, thank you. Thank you so much for the hearts. Thank you so much. Okay, so how are we doing? Well, now you might be wondering, well, what happens? You might be wondering what happens after 9. Well, 9 is 10. Do I have 10 here? So here, oh, this is 10. Okay, so cool. We have 10. 10 looks like 1 and a 0. 1 and a 0. Why do I know? How do I know? Because if you look, every place value has every column is a place value. So our ones, our tens, our hundreds, our thousands, and our 10,000. When we look, this is now 10. And then we have 11. 11 is 1 tens and 1 ones. Now we have 11. And then 12 looks like this. 12. 1, 2. That's 12, not 3. We don't want to combine them. We want to use each column is its own place value. So if our ones, our tens, our hundreds, our thousands, our 10,000s. So when we're looking, right, we want to do 5. The top beat is a value of 5, and then we have 17. How do I know 17? Because we have 1, and then we have 7. 5, 6, 7. Make sense? So then we have this. This would be 27. 2, 1, 2, and then 7. 5, 6, 7. When we're looking, we have 1, 2, 3, 4. Notice we're at the ones place. Because we're at the ones place, we now can count. Every time the beads are touching the horizontal bar, this is what's being counted. So we have 4, and then we have 5. This is what 5 looks like. The top bead will always be 5. So we have 5, 6, right? And then 7, 8, 9. And then we have 10. 10. Now we can count by tens. 10, 20, 30, 40, and then 50. Anybody have any questions? You might be wondering, why am I here? Well, just like a Pokemon, I want to choose this one. So that's why I have my ones. This is my ones indicator. My ones indicator is here. So I have my ones, my tens, my hundreds, my thousands, my 10,000. However, if I chose this one, if I chose this one, if I chose this one, then all my ones would be over here. This is my ones indicator. This dot is not a decimal. It's a indicator. It's a label to say that this is my ones. And then when we notice, we'll have our ones, our tens, but no, there's no hundreds and there's no thousands. So it's very limited. We have to be careful with what numbers we have. So that's why I choose this one over here. And then I move it all the way over here. What happens is this is our ones, our tens, our thousands, our hundred. I'm sorry, ones, tens, hundred, thousands, and 10,000. So when we're looking, we have our number. So what this number is, right? Oh, what this number is 28. So we're going to add 20 and then we add 8. So we have our tens, which is over here, our tens and our ones, just as how we have it here, our tens and our ones. When we're looking, what we're trying to do is we're trying to understand how to read the abacus. We have 36. Notice that 36 is our 30 and our 6, our 3 and our 6. Is the one always that spot, or you could choose like the one in the middle of the example? You know what? You're absolutely right, Sarah. You can choose any one. So this one is a 7-column abacus, and thank you for the question. So here, if you'll notice, I have a 13-column abacus. Why? Because size matters. Anyways, okay, so yes, it doesn't matter which dot, but I would choose a specific one. I would choose only one. That's why I said use it like a Pokemon, right? You can only use one Pokemon, so I would only choose one of them because you can only have one value of knock it off. We can only choose one ones, if that makes sense. So we have this, we can have this as the ones. So then it'll be ones, tens, hundred, thousands. Notice that the grouping of the dots is by 3. So we have, if I choose this one to be my ones, then I have this one to be thousands, millions, billions, and trillions. If I choose this one to be my ones, then I'll move it over. I know this will be my thousands. So the grouping of the dots is very specific. Does that make sense? So when we're looking, right, if I choose this one, then I have my ones, my thousands, my millions. Here, because I chose this one, oh no, I'm sorry. If I chose this one, now I have decimals. So my tens, and the decimal sits between the tenths and the tenths and the ones. Thank you, Chris. Thank you. So what we're doing is so the decimal sits right here. It doesn't sit on a place value. So we have our ones and our tenths. Then we have our hundreds and then our thousands. And that's what we're doing. And so when we're looking at it, thank you, Sarah, for the question. Anybody have any questions about abacus, let me know. And so here, when we have 36, we know that 30 is a 3, right? The 3, and our ones is a 6. So on the abacus, we have our 3 over here. This is 30, and then this is 6. So I choose this one for my ones indicator. So when I look, this is 30 and then this is 6. 5, 6. We can do it again, right? When we look at this number is 84. We know how to make 84. It's 8 tens and 4 ones. When I'm looking at it, I have 8. Do you not know what 84 is? Right? 8 tens and 4 ones. 8 and 4. So when we're looking at it, we have 4 here. We look, this is our ones. This is 1, 2, 3, 4. And then what happens? We have our 8. Our 8 is over here. This is our tens, just as we have written it out, our 8 and our 4. So we have 8, 5, 6, 7, 8. This is what 84 looks like on the abacus. We have an 8 and then we have a 4. So when we write it, we write 8, right? 84. This is what we're teaching school, right? We're teaching kids in school how to make tens and ones. We're doing 2-digit questions right now. Does that make sense, Shay? Hey, Spider-Man, I get it now. Okay, good. Okay, good. I was trying a different way to see. Did that make sense, Sarah? Okay, good, Sarah. I don't know if Shay made sense. So when we're looking at it, we want to do 3. When we do 3, we notice that there's no tens. When there's no tens, we want to use the ones. To show that on the abacus, to do 3, it looks like this. It would be 3. And on the tens, on the ones, it'd be just 3. 1, 2, 3. Notice on the abacus, it's just 1, 2, 3. So I'm just going to color it in like that, and I'll do 3. Yeah. And now we have 71. Again, 71, 7, and 1. I learned abacus in second grade, and now I do math. I see it, right? You see it. That's so cool. That's so cool, Spider-Man. I'm so happy. I'm so happy that you got the abacus going because, right? It makes a lot of sense. And when they talk about Common Core, you're like, yeah, I know it. That's so cool. That's really awesome, Spider-Man. I'm so happy. Okay, so when we do 71, how do we know what 71 looks like, right? 71 is 7 and 1. Does it matter where you start on the abacus? Hi, Erica. No, it only matters which dot you use. You could choose this one or you could choose this one like a Pokemon. So if I choose this one, then I have all my ones over here. This will be my ones, my tens, my hundreds, my thousands, my 10,000. Thank you so much, Erica, for the question. So if I choose this one, then I just need to move everything over. And now we have our ones, our tens, and then we have our hundreds, thousands, and 10,000. Oh, forcing the kids to do partial sums is now in school. Yeah, yeah, partial sums and partial quotient, which is really interesting. Okay, so what are we doing? We're going back to here. When we understand what 71 is, 71, what does that look on in the abacus? Well, if we notice, we have our place values on the abacus, right? We have 70, we have 1. 7 looks like this: 5, 6, 7, and then 1. This is what 1 is. When we're doing this, right, we want to understand how to read the abacus. We have 7, 5, 6, 7, and then there's 1. Make sense? We can count it. So if we count it and we talk about ones, we can do 1, 2, 3, 4, and then 5. On the top value, the top bead will always be 5. So we do 6, 7, 8, 9. Right, Rodolfo? Good. This is the math. Yes, exactly. When the kids do this, they're doing the abacus in their head. We can do another way. Maybe this is a little confusing because 3M is a little confused. So we can do it, right? If we did it this way, we did 1 and I have a penny. I don't know where you are in the world, but in America, this is 1 cent. So the 1 cent would look like that. That'd be 1. This is 2 cents. This is 2. And then 3 cents. This is 3. This is 4 cents. Here is 4 on the abacus. And when you look at it, well, what's 5? Well, remember in America, we use a nickel. A nickel is 5 cents. So this is not foreign concept. This is just a different way of thinking. This is 5, just like this is 5. How do you use math with it? You can do adding, subtracting, multiplication, and division. What does 10 look like? Yes, the 5 is always the blue bead. 10 looks like this. 5, right? 5. Then I'm sorry, let me finish. 6, 7, right? 5, 6, 7, 8, right? 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9, 10. 10, if you notice, is just this. It's just the 1. How do I know? Because the way we write 10, when we write 10, it's exactly the same way. It's exactly the same way. 10. 1 and a 0. We have a 1 and a 0. That's it. When we do 11, it's 11. 1 and 1. Just as how we write it. Thank you, D the Queen, so much for the rose. Ah, wait. How do the kids do mental math on? Yeah, this is how the kids do. They start with understanding how to read the abacus. Everybody needs to start how to read the abacus. Hello, E. How's it going? Yes. Does that make sense? So after 11, we can do 12. 12, what is it? It's a 1 and a 2. 1 and 2, just as we have it here. So that's why we're going here when I do 84. 84. 80 and then 4. That's what we're doing. And then right caliber, it's easy. This is cool. Thank you for the lesson. Not a problem, Luca. Luca. So then we're doing what? Let's do a couple of more. 10, yes. So 10 looks like this. 1, 0. Why? 1, 0 would be this. Our tens and our ones. So it'd be 0 and 1. Once you establish where the decimal point is, do you go from there? You establish where the ones is. So what we want to do is we want to know where the ones is. But yes, you can go from there when you understand the ones. Once you choose a dot, a ones indicator, a ones place, then you can go anywhere. It doesn't matter. Yeah. Do you search a certain workbook for toddlers? Toddlers. Oh, hey. For the toddlers, I do have a preschool abacus. And what we do is we actually do some bead recognition and more about learning how to count, like really how to count and stuff. And so when we're looking, we have you have one dinosaur, you just write the number one and then you find the one on the abacus. And then we have like just bead recognition. But yeah, it's in my TikTok shop. If you go down, there's a shop, and then like down here there's a little thing, and then other than that, there I also have it. If that's not available to you, if you don't like the TikTok shop, I am available here. Hi, my name is Lynette. I teach abacus. I've been teaching abacus for more than 20 years. This is amazing. My grandma has a wooden one. Oh, but I never learned it. But now you know, right, Caliber? Now you can learn, you can use it now. So what we're doing is we're going to learn how to add, subtract, multiply, and divide. No, thank you, Chris. Thank you. There's this one person who was so funny. I said abacus is like working out Sudoku and word problems and jigsaw puzzles. And this one person says, well, I don't know Sudoku. I go, you don't know Sudoku, but now you know abacus. Thank you guys for all your comments. Thank you so much. Thank you for the likes. So what we're doing is we're still learning how to read the abacus. I want to make sure that we understand. And I know there's a lot of people that come in now. And so what we're doing is we're doing two-digit numbers. So when we're looking at it, we have 92. And I try to break it up to show, we're doing this in mainstream math. So we do 90 and we do 2. What it looks like on the abacus would just be like that. 9 and then 2. 92, 5, 6, 7, 8, 9, and then 2, 1, 2. And you're right. The top bead will always be a value of 5 no matter what. When we do 10, it is this. 10 does not look like this because 10 is 5. This is 5 and 5. So this is not 10. This is 55, right? Every number is represented. This is not combined. This is 10. If I do this, this is not 3. This is 12. 1, 2. Make sense? Are all the beads the same color in the order? No. No, it doesn't matter. So if I choose this one, right, it's all exactly the same. It all depends if the beads are touching the horizontal bar. So the beads, when they touch the horizontal bar, now they're being counted. When they're being counted, the top bead will always be 5, no matter what. So when we're looking, we have 5. So when I do 1 and I add the 5, now we have 6. If I have 2 and I add the 5, now I have 7. If I have 3, I have 5, now I have 8. If I have 4 and I have 5, now I have 9. Ooh, Caliber, yours is a Chinese abacus. And a Chinese abacus is a little bit different, but not quite, not, it still works very similar. There are ways you can modify, right? You could just use the middles if you want to, or you can just use the whole thing. It is up to you. But what I teach is specifically the middles. So it is up to you if you want to use it. I don't, what I mean? Like you don't have to buy if you're okay with ignoring the top and the bottom beats. So when we're looking, right, we can do it too. The difference between this one and this one is that this one was before this one. It's not the first. This is not the first, but it was before the Japanese abacus. This is what we call a Chinese abacus. It's a 2 beads on top and 5 beads on the bottom. And when we look, it's very similar. So when we count 1, 2, 3, 4, and then 5. Because we have 5, now we can trade it in and we can do the top. Now we can do 6, 7, 8, 9, 10. Now we can trade it in, and because this is 5, we're going to trade it into that. Because this is 10, we want to trade to this way. So now we have 10. Whereas on the Japanese abacus, we have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then we have 10. Does that make sense, Caliber? Oh, thank you, Claire. Woo! Thank you so much. I appreciate that. I'm hoping that it makes sense, right? So what we're doing is we're just learning how to read the abacus. After a while, right, we can start doing some adding and subtracting, but we still need to understand how to read the abacus. And that is why I created this book. This is a maze book. And what we're doing is we're just doing some looking at these numbers, and we're making sure that we understand how to read the abacus. Finally, no, Tony, you're the only one who makes this understandable. You're amazing. Oh, thank you. Allie, trademark. That's funny. All right. So good. I'm so happy that you guys are understanding. It makes sense, right? It's easy, simple to use, easy to understand. Simple to use, easy to understand. So these are just questions that I have in my book. And what we're doing is just we're reviewing the place value. So here, if I do tens, which we understand, right? We have 17. We have 1 and 7. We want to break it up. We do 1, right? Just like in class, just like in grade school, we do 1 and then 7. So what does it look like on the abacus? On the abacus, it looks like 1 and then 7. Make sense? So when we're looking, the reason why I have it emptied out like this is so that you can color it in. So you color it in like that. So we can add some coloring into it. I know coloring is very popular right now. Okay. So, and then now we have 46. Again, we do 40, we do 6. We do 40, and then we do 6. And that's what it would look like on the abacus. 46. How do I know? Every column is a place value. So I have my 40 and I have my 6. My 6 is my ones. I have 40. 1, 2, 3, 4, and then 5, 6. Love the coloring. Yeah, Riley. Thank you so much. Looking at my 3 digits and I realized I didn't do the reverse one. So I was like, oh, I can't publish it yet. I just got to get it all out the door. But I was like, oh, I got to go live because I really enjoy going live. Hello, everybody. Welcome, everybody. So what we're doing is we're going to do this maze. And again, we're going to focus in understanding how to read the abacus, but we're only going to do 2 digits, if that's okay. We're going to do 2 digits and we're going to follow the maze. What this means is if you look at the number, if you look at the maze, you're going to have to let me know, what is this? I went swimming today. Oh, in my pocket while swimming. What? So did you use a whole lot of rice to dry it all up? So here, if I have my question, this is my tens, this is my ones. What number do we think this is? What number do we think this is? Yes, there, Sarah, thank you. It is 14 because we have our 1, we have a 4. Thank you, Ali. Yep. So we go 14. Thank you, Riley. So we're not going to 74, we're going to go to 14. So it takes us down to this number over here. What number do we think this is? This is an easy number. Well, this is an easy number. If I have my tens and my ones, right? Caliber. Thank you, Caliber. Yep. 2. 2 takes me over here. 2 takes me over here. Okay, cool, right? Hi, Striker. So when we're looking, right, we have our numbers 1, 2, 3, 4, and then 5. We have our tens and our ones, tens and ones, tens and ones. So what's going to happen is my tens, 5, 6, 7, and my ones, 5, 6, 7, 8. Thank you, Nancy. Why do I work in the middle? Yes, you know why? Because I have an indicator right here. 78. 78. Hey, Jeffers, welcome. 78. 70. 5, 6, 7, 8. 5, 6, 7, 8. The reason why I'm here is because this is my, if you look at, there's a dot here. This dot is my ones indicator, my label. This labels my ones. So just like that Pokemon, just like a Pokemon, I choose this one. You could choose this one, but then you'd be over here, right? But this would be my ones. And then you'll notice there's not enough room for hundreds, thousands, and 10,000. So, right, we have 78, so it takes us over to here. What Does that make sense? And so when we're looking at it, thank you, baby squirrel. Baby squirrel. Huh. I wonder if there's going to be a song out of baby squirrel. That'd be funny. Jeffers, you're so fast. Yes, so at my tens and my ones, that'd be 22. Thank you. Yeah, no, thank you, Nancy. Thank you so much for the question. Let me know if you have any more questions. So thank you, Caliber. It is 22. And we're going to keep going down this way, and now we're over here. This one's easy. This one is easy. My tens and my ones, I have my tens. I'm so still confused. Oh, Striker, 10. So when we look, this is 10. Thank you, Sarah. Thank you, Jeffers, Caliber, and Riley. So this is 10. How do I know that this is 10? Because I have my zero, my ones, and my tens. When we're looking, hang on, Striker, hang on. Here is 3. When we do 3, right? When we do 3, what are we doing? 3, I'm sorry, 1, 2, 3. Striker, did that make sense? 1, 2, 3. Thank you, Jeffers. So the answer is 33. That's funny. That's it. So when we add this, what number is this? This is 34. And then I add another number, right? What do I do about 5? 5 will always be the top bead, right? So this is 35. 35. The top bead will always be 5. Then we do 6. Does that make sense, Striker? Does it matter which bead I move? No, it doesn't matter. It just matters how you add it all together. So here, when I show you this, right? What number do we see here? We have this number. This is my tens. This is my ones. If I have my tens and I have my ones, what number? Right? So we have our ones and our tens. This is 5, 6. Thank you, Jeffers. 5, 6. This is 6. And then we have 9. 5, 6, 7, 8, 9. Does that make sense, Striker? So we have 96, just as Jeffers says. And then we have this one, right? And then we have our tens and our ones. Our tens and our ones. Notice that we have 2. Yes, thank you, Caliber. 82. 5, 6, 7, 8, and then 2. Thank you, Sandra. Thank you, Riley. Thank you, Caliber. Now we have this number. We have our tens and our ones. We have our tens, 5, 6, 7, and then we have our ones, 5, 6. Thank you, Ali. Thank you, Jeffers. Thank you, Sandra. Yes, 67. So we're over here now. And then this will be easy because it's only one digit. Blue are always 5. Yes, Nancy, blue is always 5. The top beat is always 5. So when I just do my ones and there's no 0, there's no tens, right, Caliber, Jeffer. So when we look, so the blue beat is 5 and 10. No, Striker. Just, oh, hey, thank you so much. The blue bead is not 10. The blue bead is 5. Ah, don't forget to smile. Welcome back. Yes, thank you so much. It's 8. So when we're looking, Striker, when we do this, this is not 10. This is 5 and 5. That's 10. 5 and 5. That's 55. This is 10. So what's my next one? Thank you, Jeffers. We have 60, right, on our abacus. This is my tens. This is my ones. I have 6, 5, 6, and then we have 9. 5, 6, 7, 8, 9. 10 meaning tens place, 1 meaning 1 place. Yes, Angel, yes. Thank you. So when we're looking, we have this. We have our ones and our tens. So the number is actually 69. Why? 61 looks like this. 60 and then 1. So our tens is this, 10. We have 9, 10, 11, 12, 13, 14, 15, right? And then it takes us to here. And then our final answer is, oh yeah. The final answer to the universe is, can you teach me how this game works? Jeffers. Thank you, Jeffers. Yes, 42, right? The answer to the universe is 42. How do I know it's 42? Because I have 4. 1, 2, 3, 4, and then 2. 1, 2. Put it together, and we get 42. What does this provide in learning process? Just dropped in. I'm sure I'm being redundant. Sarah, what? Sarah, www. What is this providing? It's providing learning. What is it? Number fluency, number sense, number fundamentals, arithmetic, and it fills the gaps of adding and subtracting, multiplication, division. We can do adding, subtracting, multiplication, and division on the abacus. It's interesting because you can actually see the numbers as well as understanding there's a yes decimal place. The decimal place what happens between the ones and the tens. So every column is a place value. So when we're looking at it, I heard it helps basic. Yes, thank you. So let's do x is equal to mx plus b. Hi, Brian Castaneda. Oh, make sense? Yeah. So what we're doing is we're understanding how to read the abacus. We're done with this. We're done. We're done. Because Brian wants to do y equals mx plus b. Y is equal to mx plus b. Let me think. Let me think. If we did if we did y is equal to mx plus b. Let's put a pin in that. No, I need to learn abacus. We do a little bit of beginning of algebra, and we can do that when we start talking about when we don't have enough beads. But the first thing we're going to do is understand when we move the beads, right? We want to be happy and we want to be gentle when we move the beads. Ah, thank you, Riley, for the heart. So what's going to happen is you're going to use your fingers to move the beads like this. You know, even though your hands might be big and burly, you can still use it. You can even use your toes to move the beads if you're very ambidextrous. Abacus is math, what phonics is to reading. Ooh, that's a good one. What's up, Buttercup? That's a good one. I think so, right? I think so. I think phonics is to yeah, it could be that. So when we're looking at it, when we're doing six, we do six. When we do seven, right? Notice that I'm touching the edges of the beads. So when we're working with it, you don't want to be aggressive. And when if I have my answer here and I do this, you don't want to flick too hard because then your answers will become wrong. It's very easy to move. It's like a little rattle. So you're going to use your left hand to stabilize it, and then from here you can use the move the beads. But make sure when you move the beads, you want to do it with intention. Okay. So, but what happens is what abacus is the gateway to complex math. So we actually do something like this, but not quite. Ah, thank you, Ali. So we do something like this, but not really like this, if that makes sense. Okay. So, but thank you for this. I will use it in my future lives. All right. So what are we gonna do? One, two, three, four. We're gonna be adding and subtracting now. So what we're gonna do? Whoa! We're gonna do some adding and subtracting because we know how to read the beats. We know how to read the beats. When we know how to read the beats, then we need to understand. What are we trying to understand? We need to understand. We need to understand that we are looking at the add-in. Action. Yes, I've been well. I've been well. I've been on TikTok for a little bit. Welcome back. Welcome back. So, what we're doing is we're going to understand add in. What does that mean? Well, in the school, we focus on the result, but in Abacus, what we do is we want to focus on the add in. When we focus on the add in, we want to know can we do it? So, here's the question is 7. Can we add the 1? Can we add it? Yes, we can. So my final answer is 8. Again, you'll notice that what we're trying to do is making sure that we understand how to do the add-in. Thank you, Jeffers. Thank you, Stryker. So we're going to do it again with the 2. When we do the 2, we have 5. When we add the 2, can we do it? Yes, we can. We can add the two. So these are very simple questions, but they start to do the critical thinking. And as you go through, we're going to start doing. We start adding three. When we add the three, you could add the five, right? We add the five, and then we add the three. We know that this is eight. You could do it you could do it the mainstream way, but then there's a lot of counting and a lot of dots. And so it's interesting, but we don't need to do it on the abacus because now we can actually subitize. We can say five and then three. I know that's eight. I know if I do this, this is one and four, that's nine. Easy, right? So what we're trying to do is we're trying to understand how easy it is to use the abacus and how you're able to visually see what you're doing. Four is just plus the four. Notice when I add the four, I want to go to the horizontal bar. When I subtract, I'm going away from the horizontal bar. So what I'm trying to do is show you when I add, I go to the horizontal bar. When I subtract, I'm going away from the horizontal bar. And so when we know how to add, we know how to subtract. So when I have two, I'm going to add the two. When I subtract, I want to take away the one. I'm sorry. I have two, I want to add the two. Subtract one, I take away the one. I don't know if it's just a me hard to read comments, but the light colors with the dark colors mixes in. Hard to read comments that are light colored with light colored background is just So after that we have two. We know how to do one again in the abacus world. In the abacus world, what we're going to do is we're going to understand how to take away the two. We have three, and then we take away the two. We have three, and then take away the two. Are you talking about the abacus? The light colored with the light colored background. I'm not sure what it means. Hey, RTX, welcome! Hello again. Hello, hello, hello. It's like old times. It's just everybody here. No, actually, the video and me typing. I don't know. It, you could. I don't know if it's not. I don't know. Okay, so we have this and we have three. And then when we have three, we're going to add the four and then we're going to take away the three. When we take away the three, that's what we're doing. We take away the three. We take away the three from the horizontal bar. So that's what we're doing. We take away the three, right? And then we add the four. Again, if you notice, when we do the adding and subtracting, these are not new strategies. You're just adding, you do the same thing, but just the opposite. Whereas in mainstream math, what they do is they give you different strategies on how to add and how to subtract. But in abacus, if you know how to add, you will just do the reverse, which is subtract. That's all you're doing. Can we do two-digit numbers? Yeah, we can do two-digit numbers. But right now, let's just learn how to learn how to move the beads, if that's okay. And then we're going to go into higher digits. But right now, I just want to show the fundamentals. That's what we're doing is we're understanding how to use the fundamentals. I don't know if anybody's watched Karate Kid. Well, Jackie Chan has one scene where he says, "Put the jacket on, take the jacket off. Put the jacket on, take the jacket off." That's what we're doing is we're understanding the fundamentals. We're learning how to put the jacket on, and then we're going to learn how to take the jacket off. Does that make sense, Striker? So the first thing we want to do is we want to understand the fundamentals, and then I'll show you how it gets scaled. But the first thing to do is understand when I want to add six, right? I want to add five and six, and I bring it together. When I take away, I swear math will always be. So when I take away, this is minus 6. I add 6, I take away the 6. And it's the same thing with the 7. If I have 2 and I want to add the 7, I want to add 7 and I want to take away the 7. So now you'll see there's a number pattern. I want to add the 7, I want to take away the 7. Add the 7, take away the 7. I need to get that sound bit. Put the jacket on, take the jacket off. Put the jacket on, take the jacket off. So what we do is we want to add the 6, take away the 6. If I did 8, I want to add 8, I want to take away the 8. So now we understand, right? Always be my favorite term. Okay, so that's it. I mean, as far as we go up to 9. And that's it. All right. So now what we're going to do is the question might be, what happens? I use this for college math. Can I use this for college algebra? No, you can't. Because algebra is all about the variables and about the uh, the unknown. So you can only do arithmetic. Okay, so we did this, we did this. Okay, we did this. So the question might be, what happens when we don't have enough beads? Okay. Okay, so here's the question. What happens when we don't have enough beads? When we don't have enough beads, we are we're stuck. We don't know what to do, right? Because remember, the question is, if I have two, I want to add another two. If I have two and I want to add another two, I have four. So what we're doing is we're trying to see how many beads we have. The question here is when we don't have enough. What happens when we don't have enough? When we don't have enough, we have to utilize this concept. This concept is what's being taught in school, how to make a five. When we know how to make a five, we're going to utilize utilize the top bead. We're going to make our beads work for us. We're no longer going to have any freeloading numbers. So what's going to happen is when I want to add the five, right? Oh, here's the question. If I have three on my abacus, let me represent three with my pennies. So this is three. One, two, three. And then what I'm going to do is I want to add four. But guess what? I don't have any more beads to add four. This is money, right? We know this is money. See you later, Caliber. Have a good night. I hope to see you in my next live. So what's going to happen is this is three. Sheep, does this make sense? This is three. One, two, three. One, two, three. And then what we're going to do is we're going to add the four. But guess what? I have a nickel. Because I have a nickel, thank you, Jeffers. Because I have a nickel, I'm going to give you my nickel. But notice that's too much. So I need to take away the one. I can do the same thing on the abacus. I'm going to give you the five, but I need to take away the one. So my final answer is seven. Does that make sense, sheep? So when we're looking, the five will always be the top bead. The bottom beads is always has a value of one. One, two, three, four. So if I look, this is four. If I did this number, right? If I have four and want to add another four, I have four beads on the abacus. I have four beads and I have four pennies, but I want to add another four. Because I want to add another four, I don't have enough, but I have a nickel. A nickel is enough. A nickel is 5 cents. It's enough. So what do? I'm going to give you my nickel, right? I'm going to give you my nickel, but I need to take away one to balance out the equation. So if I take away this one, my final answer is now 8. Does that make sense? Are we okay? How are we doing? If not, we're going to continue on. Let me know. I can slow down. All right. So here we have 2. When we have 2, I'm going to put 2 on my abacus. If I have 2 and then I have 4, because I have 4, what am I going to do? I'm going to add this 5. Because I add the 5, it's too much. I need to take away the 1, just as Jeffers mentioned. So I can add it 5, and I'm going to take away the 1. So my final answer is now 6. Does that make sense? And we could do it again here. So we have 1. If I have 1 and I need to add 4, but that's not enough. I have 5 cents. Because I have 5 cents, I'm going to give you my 5 cents, but that's too much. I'm going to give you the 5 cents, but that's too much. So I need to take away the 1. So I need to take away the 1. Astro, right? So my final answer is 1. All right. So we can do it again. You know what? We can do it again. But you know what? This time we'll do it with a 3. When we do it at 3, what if you notice we're not going to memorize 3 plus 3. What we're going to do is we're going to understand this concept, how to make a 5. Each column in the 5, yes, sheep, yes. So what we're looking is 3, 1, 2, 3. I want to add 3 again. Because I want to add 3, I don't have enough. Whoa, I don't have enough. But guess what? I have 5 cents. 5 cents is the same thing as this blue bead, just as Sheep has mentioned. 5 cents is the same thing as this blue bead. But that's too much. I only need to give you 3, so I need to get change back. Because I want change back, I just need 2. So now we balanced it, right? I give you the 5, that's too much. I'm only giving you for 3. I need change back. So I'm going to take away 2. So my final answer is now 6. We could do it again. Astro, are you ready? So we have 4. We have 4 on the abacus. I need to add 3. Because I need to add 3, I have 5 cents. Because I have 5 cents, I'm going to give you my 5 cents, but that's too much. I need to take away 2. So my final answer is 7. I can show it again on the abacus. I gave you my 5 cents, but I need change back. I need 2. So my final answer is 7. Is that only the particular abacus or is it depending on the type? No, all abacus is the same. You can do it again with this one, right? So if I had 4, I'm going to do it again. If I have 4, 4 on the abacus, right? 1, 2, 3, 4. I have 3. I want to add 3, but I have 5 cents. I have enough, but I don't have it in separate, right? So I'm going to give you my 5 cents. It's too much. I need to take away the 2. I can repeat it again, add the 5, take away the 2. My final answer is 7. Did that make sense, sheep? Unless, right? Difficulty reading chart due to the contrast issues. I just haven't seen one with a divider. Oh, yeah. See, the one with the divider. Okay. So the one that you've seen is probably a 10. It's probably a 10 bead column that goes this way. I don't know how to use that one. I don't teach that. Yeah. Okay, Chris. See you next time. Yay, Panda, Midnight Mathers. Yeah. So sheep, the one that you've seen is the one that goes 10 beat across. I don't have an example of that. But yeah, and they do, it's interesting because they do place values, but you got to kind of turn your head. Difficulty reading the chart due to the contrast issues. Okay, thank you, Sarah. I will take a look at it. Yeah, not a problem. That's a good question. Yeah. And yeah, thank you. No, that's a very good question. Thank you, sheep. Okay, Astro. I don't know if Astro is here. I'm trying to my best to hop in when you're live, lady. Oh, thank you. I appreciate that. I appreciate that. Thank you so much. What is mental math? Mental math is when you put it in your head and and you can like see the abacus in your brain. Can I do it? Not really, but you can. I would love to be able to read people's input and chats. I think honestly, I think it's a comment from like I think it's your view. I'm not sure, Sarah. Like I haven't done anything. This is all just very generic stuff. If you're talking about the chats and the thing, let me see. Let me see. Now I'm curious. It could just be. Oh, you know what? I think it's a. I think it's I don't know. I don't know why. Maybe it's an update in TikTok. That is difficult to see. Yeah, I don't know. That's not me though. That's a TikTok thing. Inception. Yeah. Oh yeah. Yeah, I apologize. You know what? You know what, Sarah? If you could, I would watch me on your desktop. You could do that. The reason why I have it cuz like yeah. Yeah, yeah. Oh, and then that's the my shopping cart is over here and my service is over here. So if you guys want if you guys want if you guys want a printout of the reference, I give this to you for free. All you got to do is click on this link at the bottom that says service. If I only had one. Or you could watch me on the iPad. Maybe that'd be better. But yeah, this service link will give you a little DM. You can DM me, and then I can give you the link for worksheets. And the worksheet I'll give you would be this abacus reference sheet if you're up to it, if you want one. Just so you know. But yeah, I'm trying to see that. Yeah, that's interesting. And you're right. I didn't quite notice that. But you know what, Sarah? You know what you could do? Change your uh change your settings on your phone to do nighttime display. Maybe that will help you. You know what I mean? So I did dark mode. Unfortunately, that didn't work. Oh, then I don't know. I get stuck at the 10 place number. I feel like I forget somehow to count. Oh, hey, Tropical Paradise. The 10. The tens places, I feel like I forget to count since I'm new to it. Yeah, it's unfamiliar. That's all it is. And then when we do it, right, we have our tens 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and then we have 100. 100. Yeah. Yeah, I feel like it's just being familiar. But you're right, it's because you're new to it. And I mean, you can't really compare, right? Because the people that do come by and visit, like Panda. I mean, Panda's been with me for a few months, and I go on quite often. So it's kind of easy for like some of the people that answer quickly, like Jeffers. Oh, Jeffers is it 2 digit now? Does it only work with whole numbers? It's decimal numbers. Yeah, we can do decimal numbers too. We can do decimal numbers because a decimal just happens to be another place value. That's all it is. So if this is my ones, then I do my tenths over here and my hundredths over here. Oh, so right. Okay. Thank you for the reminder. Here. So this is how we can scale it. So Striker, let me give you a better one. Let's do a 5 digit number. We can do a 5 digit number. When we do a 5 digit number, yeah, we only do whole numbers. You can do fractions, but fractions is just another way of dividing. So you can do adding, subtracting, multiplication, division. But because we can do adding, subtracting, multiplication, division, we can also do decimals as well. Right. Because it's just another column. And then if anybody's interested, I do sell on this or in my TikTok shop if you're looking for workbooks. Hi, my name is Lynette. I've been teaching abacus for 20 years now, and I'm really enjoying to teach the world how to use the abacus. And so we are doing this over, and we're going to review. So here's the question: 13,000, that's 13, 578. We know how to read that, right? We have that 13,578. So what we're going to do is we're going to add. When we add, we have this. Can we add the 2? Yes, we can. We can add the 2. Can we add the 4? Can we add the 4? Yes or no? No. So what can we do? Do you remember what to do? Do you remember what we did? When I want to add the 4, do you remember we had it here? Plus the 4 is equal to plus the 5 minus the 1. Plus the 5 minus the 1. And then I go here. Plus the 3, I add the 3. Add the 1, I add the 1. I add one more, and then I add this one. So my final answer is 337,889. Did that make sense? So when you understand the basics, then it becomes versatile. When you understand the basics, then we can scale it up to other numbers. So we can do this one. Let's see how this works. If we did this number, we had 283. And now what we do is want to add 511. We don't need to do, in mainstream math, I know they talk about friendly numbers, but we don't need to do that. We just need to see, can we do it? Ha, magic. So what happens is I want to ask, can I add the 5? Yes, all I got to do is add my 5. Do you see that? If I add my 1 and I add another 1, that's all I'm doing. So my final answer is 794. We can do it again. Let's do it again. Let's do 26. 26. There's your double digits, sheep. Was it sheep? Right? No, striker. Striker, there's your double digits. 26. When we add the 26, we're going to add the 32. When we add 32, how do we do it? Can we add the 3? No, we cannot add the 3. But guess what? We know how to add the 3. We know how to add the 3. It's plus the 3 is equal to plus the 5 minus the 2. So we're going to plus the 5 minus the 2. And then what are we going to do? We're going to add the 2. Can we add the 2? Yes, we can add the 2. We're going to add 2 just like that. My final answer is 58. Can abacus help with factors? What kind of factors? I struggle with his age. What do you mean by factors? Like fact families? Because that's what we're doing is we are doing fact families. If you notice when we add the 5, when we add the 2, I need to find my ugh, there it is. When we do this is a fact family. List factors of 9, as in list the factors of 9. We don't do factors of 9. We only do factors of 5, and we do factors of 10, and then it can go all over the place. Can we do more addition problems? Oh yeah. Yep, we can do more addition problems. Does that make sense? Sarah? Yeah. So, there's a whole bunch of numbers. There's a whole bunch of numbers. I was looking at it, and they do like 7. What is it? Let's let's do it. Let's do it. Let's do the whole fact family of 9, right? 9. Okay, right. So we do 1, 3, right? 1, 3, 9. Is that what we're doing? We do 1 plus 8, 2 plus 7, 3 plus 6. But in abacus, it doesn't matter. Because if I do 1 and I want to add the 8, right, it doesn't matter. Because what we're doing is we're looking at this 8. Can we add the 8? Yes, we can add the 8. You can see if I have 2, I have 7 here. 5, 6, 7, and I add the 7. If I want to do 3, I have 3, and I have 6. 5, 6, and I add it together. Is that what you mean, Sarah? How do you do it if the number is bigger than 5? Ooh, tropical paradise. Yes, Khaleesi, we can do multiplication, but I have to put a pin in that because right now we're going to go into how to make a 10. But before we go to how to bigger than 5, that's a good question. Tropical paradise. 5 plus 5. Yes. So we do 5 plus 5. When we do 5 plus 5, what are we going to do? We're going to understand that we don't have enough beads to add the 5. But guess what? Guess what concept we teach the kids? We teach the kids how to add a 5. To make a 5, they do 5 plus 5 is 10. This is a concept we're teaching. That's fine, right? We know that 5 and 5 are partners. Because they're partners, then we can do it. On the abacus, right, we have 5. What are we going to do? What we're going to do is we're going to power up our abacus, power up our addition formula. So what does that mean? We're going to power it up. When we power it up, we're going to utilize it for its fullest potential. So what does that mean? We're going to isolate the variable. This is the variable that we're going to isolate, right? The 5. When we do 5 plus 5, that's what we're going to do. Plus the 10 minus the 5. When we plus the 10, what happens? When we plus the 10, plus the 10, 1, 0, 1, 0. And then we take away the 5. We take away the 5. My final answer is 10. Does that make sense? Factors of 27. Oh, yeah. So, factors of 27, he would really need to know his multiplication facts. Does that help with the abacus? Abacus doesn't do factors like that. So when we're looking at factors of 52, yeah, he would have to know how to make it. So ideally, that's a more of a multiplication thing. Yeah. No, thank you. Thank you, Sarah, for the examples. But yeah, we're not there. When we do that, that's a multiplication thing. But he has to know that in his head. What we do on abacus is track the numbers. And what we can do, track the numbers, is meaning what? It means that we can do like additive cumulative addition, or we could do distributive property, but we don't do factors of 52. Yeah. Thank you, Tropical Paradise. Thank you. Thank you for explaining. I'm glad I found it fun. Thank you. Yeah. So even we do distributive property on the abacus. That's when we do multiplication. And then in multiplication, we also do division. When we do division, we do partial quotient. But again, see, the thing is these are all concepts that abacus world doesn't talk about. Only I talk about it. So when you're talking about factoring, I'm thinking about the factoring. It's interesting, but I don't think abacus does it. I'd love to have him utilize this when he was younger, but still applicable now. It is still very applicable because it will It is a gateway to complex math. So what we do when we did the isolating the variable, that's very similar to algebra. So there's that one person that mentioned, I don't know, x equals, oh, the question is mx, y is equal to mx plus b. That's what we did right here. Kinda, right? Kinda. And then what do we do is we substituted this information into here. So if I wanted to add the 5, or I do another question, let me do another question. Here's another sample question. If I want to add the 6, so here's my question, 9. If I want to add the 9 and I have a 6, if I don't have enough beats to add the 6, I know I'm going to substitute. I have this concept to substitute, plus the 10 minus the 4. So my final answer is 7. So when we're doing this Christmas is very special because of Christmas time. Whoa, yeah, that's pretty cool. My It's funny. No, that's fantastic. That's fantastic. And you know what? Algebra, and it should be that way because why? The elementary school math is not it doesn't make sense, elementary school math. And I think there's a lot of strategies that happen in elementary school math that is not applicable anywhere. So yeah. Yeah, it's very interesting. Why is it 7? No, this is not 7. This is 15. So my question is here. This is 9. So this is 9. I want to add 6. When I add 6, I want to add the 10, take away the 4. So I add the 10 and then I take away the 4. So my final answer is 15. Once they added the alphabets to math, I was lost. See, the alphabets is not, it's the same thing here, right? But see, that's what I'm saying. Abacus is the gateway to complex math. Let me replace this, right? If I replaced it with x is equal to, I'm sorry, let me do that again. X plus 4 is equal to 10. Does that make sense, sheep? So what did we do? We're going to isolate this variable. We take this x, we move it to this side. So we have x is equal to plus the 10 minus 4. So what we did is exactly the same, but we know the numbers. If you have trouble with this, you didn't pay attention in class. Basically, you're subtracting. Yes. And everything is scalable because of that. Yes. Once you know how to add the 5 and subtract the 5, you know those pairs, everything is scalable. That's the secret to adding and subtracting. Does that make sense? Yeah. When I started looking at it, I was like, oh my God, you only need to know how to add and subtract. You only need to know how to make a 5 and how to make a 10. You know this down solid, you can subtract and you can subtract and add anything under the sun. It just matters on how far and how, and then there's a loop that happens to it. Shaming having troubles in class, not a good thing. We all come from different struggles. That's very true. That's very true, Sarah. And I don't understand why people say that, right? Like, why you have trouble? You didn't pay attention in class. There's different. We don't know what's going on with people's lives, right? Like, school is just one aspect, really one small thing, right? Yeah, it's total true. We don't know. There's no judging. I don't. Yeah, I understand. But tropical paradise, oh my God, right? So that's the fantastic thing, right? It's so amazing. Oh yeah, it's beautiful. It's beautiful. I was going through as I was making this thing. Okay, so what we did is we made a 5. When we made a 5, right? When we made a 5, we add the 5, we make a 4, we make a 3, we make a 2. We have this concept of how to make a 5. Then what do we do? Hydrate. Then what do? We make a 10. When we make a 10, okay, this is the best part. This is the best part. Zen, put it back. Yeah. No, this is the best part. Tropical paradise. When we're here, let me do this. Tropical paradise. We do 7. Let me show you how beautiful this is. We're going to do 7. When we add the 7, right? My question is, can we add the 4? No, we can't add the 4. We don't have any more beads to add the 4. So what are we going to do? Well, we cannot add the 4. So we're going to start doing critical thinking. When we do critical thinking, right? Can we add the 5? No, we cannot add the 5. So we cannot use this 5. What are we going to do? We have to use this plus the 10. When we add the 10, we know when we add the 4, we have to plus the 10 minus the 6. So we're going to plus the 10 minus the 6. My final answer is 11. So what did I just do? What we're doing is we're understanding how to critically think. In school, we don't teach the kids have a conversation with our numbers, but in abacus world, we teach the kids how to critically think and understand what the numbers are. And we can do it again with subtraction. Subtraction is exactly the same workflow, and it's really quite amazing. It's really amazing. And any number you have, and now we can do double digits. Let me see if I can bring that up. But it's so amazing. Like it's so simple and yet it's amazing. Oh, thank you, Sarah. I'm in math. I've been teaching abacus for 20 years. I teach abacus professionally. I don't know if it's professionally. Oh, Ali Boxer, who hurt you? Ah, are you sad? Oh, that's so sad. Okay, but thank you, Sarah. Yes, right? Oh my God, it's amazing. So let's do, where is it? Where, wait, we want to do we want to do two digits. Striker wanted two digits, and I was building out my stuff. So, and because the reason why is it takes a little time to build out, like it takes time to build out abacus questions. The reason why is because it's very focused. Why? In abacus there's number patterns. It's so interesting. Abacus shows me that there's a number pattern to math. So if you notice, we did this, which means this is the simple one, right? So what does that mean? When we add 2, is there enough to add the 2? Yes, there's enough to add the 2. Here is the 5. We added that 5. We can make a 5. How to make a 5, right? We added the 4, and then we add another 4. We plus the 5 minus the 1. So what are we going to do? After we add the 5, then we do this. We make a 10. Because we make a 10, because we make a 10, right? Let's do 6. 9, right? 9 plus 6. Plus 6 is plus the 10 minus the 4 is 15. You're so sad, Ali Boxer. I'm going to have to. Oh, I'm sorry. Okay, so, wow, we're roughly. Okay, so how are we doing? Oh, so I've been teaching abacus for about 20 years, and I'm now putting it onto the internet. I have online classes, but they are pre-recorded classes. I do offer tutoring, and but if they're tutoring, it's like one-on-one. And if you want to know more, I have a services button in my next down at the bottom. I have a services button down here if you want to know more. Just DM me and I will we'll talk. And we'll do a little meet and greet and see if your child or you are interested in more abacus. Yeah? Okay. So, yeah, no, not a problem. Thank you. Okay. So, where is Erica? Erica, more examples. Okay. So, more examples. Yeah. Oh, I was going to get you the questions. That's what it was. So what we can do is we can do, what do we call, um carrying over, right? Carrying over. Yeah, I need to clean this up. We can do single digit. Are we okay with single digit, or do you want to do double digit? Inception again. So do you want to do single digit, double digit? Okay, we'll do double digit. Let me go back. Start with the single. Okay. Let me go with the single first, and then we'll go double digit. This will be easy. This will be easy. So here. So we have 9. And then what do? We have to add the 1. There's not enough beads to add the 1. Because there's not enough beads to add the 1, what are we going to do? We know this. we want to do is plus the 10 minus the 1. So we want to plus the 10 minus the 1. I'm sorry, we're adding the 1. So we're having 10. I'm sorry, let me start over. 9 plus 1. There's not enough beads to plus the 1. So what are we going to do? We're going to plus the 1 is equal to plus the 10 minus the 9. So plus the 10 minus the 9. And then I'm going to do 9. When I add the 9, that's all I got to do. So my final answer is 19. When we do it again, let's see, we do it again. Um, oh, this is ones. Here, let's do it again. So we have 8. We have 8 on the abacus. When we have 8 on the abacus, we want to take away the 2. Take away the 2, there's enough. All we got to do is take away the 2. When we add the 9, what do we do? To add the 9, we know what? We add the 9 is what? Plus the 10 minus the 1. So what we're going to do, we're going to plus the 10 minus the 1. We minus the 1. And then we add the 5. What? Can't add the 5. What do? We know how to add the 5. Adding the 5 is what? Plus the 10 minus the 5. We plus the 10 minus the 5. And my final answer is now 20. And if you look, this is a puzzle, and the answers are right here. You have to cut it out. So what I was trying to do is I was trying to get the kids to practice their motor skills. This is way better to teach our kids. Yeah, I thank you. Ari, yeah, thank you so much. I was trying, right? And that's the hope. That's the hope. That's the hope to try to teach everybody and to carry on. I mean, I get a lot of kids to come in, but I also get a lot of kids that also are very interested in it. So it's not just a kid thing. It's a person that's open to new things. To binary addition, somebody said it's binary. I don't know. I don't know how to do binary, so that's above my pay grade. Are all these diagrams your creative? Yes. Acquiring Creative Commons or acquiring Creative Commons content. These are all mine. This is all my workbooks. All of these workbooks that I created all came from me. And so this one is the hidden word, and we could do it again, right, with the hidden word. This is about finding the answer, and then you put the answer down at the bottom. And then I have answer sheets. This is the maze. We did the maze, but this time the maze is how to add the 10. Or, yeah, how to add the 10. So when we're adding the 10, you find the answer. So here's the question, right? The question is 9. I have the 9. I take away the 6. I take away the 6. I add the 9. I know plus the 10 minus the 1. And I do it again. Plus the 10 minus the 1. So my final answer is 21. So I follow the answer to go down here. For real? Yeah. Yeah, these are all mine. So I'm on my 10th I'm in the process of doing my 10th book. But I have this one and this one. And then the books are very specific. The reason why is because I wanted the kids the the purpose with the book was for children to practice their numbers. And so what I did was everything in this book is about adding the 5. And then this one was about adding the 10. And then I have another one where we're taking away. We take away the 5. And so these are separate concepts, but once you understand these concepts, then the sky is the limit. But the thing is to get them to understand how to utilize it. And so when we do the minus, it's the same. We have we have this. So if we have 8, right? We have 8. I have 8 on my abacus. And then I want to take away the 4. Again, to take away the 4, it's minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. So my final answer is 4. Yeah, I'm very curious about cognitive transitions after moving away from the abacus. I'm sure that I want to hear from you. Oh, okay. What age do you recommend to start teaching the abacus and where and how to start? Thank you, Sheep, for joining. Thank you. I appreciate that. Thank you so much for joining. Um, I was trying to get to the kids younger, Nancy. So uh, I was trying to start them young, to start them as young as preschools. I think as young as I started would be 3 years old. Usually was it 3, 4, and 5 is where I was trying to get to. But after they know their fives, then they would go into understanding how to do this. So then this would be like six, seven, eight. But they don't go by ages, right? They go by concepts. So once you finish the preschool of adding, simple adding and subtracting, then you go into adding the five and taking away the five. And it goes really quick after that. So with my kids, they actually started knowing their multiplication table in first grade because we needed to do that in abacus, if that makes sense. Um, I need this for myself. I don't understand. Hello, Alo. Um, Sarah, I'm sure I don't know what PMID articles are. I'm sorry. I don't know. I don't know acronyms. I don't know what that is. And then it's been interesting. Can we show how to use it? Yeah. Mirka. Yeah. Okay. So let's do a review. So we can do a review. We're going to do one. Oh, what are we doing? Let's do a review. Let's do a review. So yeah, these are all my books. Did that make sense, Nancy? I hope that made sense. Um, so when we're looking, this is an abacus. We have the top beads and we have the bottom beads, right? We have our top beads and we have our bottom beads. This is the beam. This is the horizontal bar. This horizontal bar is what tracks us, tracks the beads. So when we're adding the number, right, we have zero. None of the beads are touching the horizontal bar. So when we have one, this is one. We have two, this is two. Three, four. After four, this is a value of five. Because it's a value of five, we can add one. Now it gives me six. And then we have seven, five, six, seven. We have eight, five, six, seven, eight, and then nine. Five, six, seven, eight, nine. And then after nine is 10. This is a unique number assigned to each. I've heard of PubMed. Yep. Basically, research in the articles. Yeah, there's not too many research on the abacus with children or even with adults, but there those that are there, I did read that it's interesting on how the kids, when they're doing business transactions, they have a stronger sense of numbers than the American kids, because the American kids have a lot of just understanding the abstract, but they don't solidify it with the number, with the abacus. They don't solidify it with concrete things, whereas in other countries they solidify it with other objects or other things, and they're always constantly working with it. And so the interesting thing about it, I feel like, is that I we push the kids very quickly to do things mentally, which is very interesting. I've only seen them used in, so interesting. America, that's funny. Yeah, abacus is in a lot of places. Where did you see it, Mirka? What movies have you seen it? I know it's in Soul. It's in Fairy Mary. No, Tinkerbell. Fairy Mary uses it. We have Penguins of Madagascar. Wonka, there's a character named Abacus Crunch. What else? I believe it. Our children are not learning hands on, they're learning abstractly. Yeah. Tinkerbell. Yeah, Tinkerbell. Fairy Mary uses it. Yeah, and I don't know why we push the kids to do. I don't know why mental math is such a thing that everybody wants them to do. Because even in abacus world, people still use the abacus all the way till like, till like till like they're old. And you could go to mental math if you really wanted to, but I think using the abacus is crucial. They change the curriculum. They do change the curriculum, and they do a lot of different strategies. So this one is my book, and so this is just activities on how to recognize the numbers with the numbers with the abacus numbers, and that's what it is. My nephew's homework is a lot different than what I did. Yeah, and that was the interesting. There's this one where I was looking at number bonds, and I'm like, oh my god, really? So there was this one where, here, I can show you. There's this one where they were doing let's see, let's do this. So there was this one where they did 67 plus 54. Okay, that's fine. And so El Dorado. Really? I'll have to look at that one. I have to make a note of it. El Dorado. I make notes of all of the movies that have abacus. I will look for it. Okay. Oh, there was also used in SpongeBob. SpongeBob. It's like sleep training, expecting to. Yeah, that's what it was. I don't like self-soothing. I don't like self-soothing. I just don't like it. Okay, so let's go back. So here was interesting. Um, so there was these number bonds, and they're like, okay, well, let's break this up. We do this, right? We have 70. We have 6, and I know the difference is the difference between here is what the difference is. The paper is still a picture, and it's really interesting. And it's like when I look at the abacus, when I look at this abacus, even on a picture, it doesn't translate as well as the actual physical thing. And I think it's because it's 3D. I don't know what it is. But yeah, great fiction currently I'm reading, including Mother Hunger. Highly recommended. Huh, interesting. Interesting. Mother Hunger. I'll take a look at that. Um, but yeah, I find, even pictorially, it still doesn't it still doesn't grab, like it still doesn't make sense to me. So that's why, like, doing something like this, it makes me so mad. And then what do? They combine this together, right? So this is 12, and they combine this together, and then this is 10, right? And then they combine it again. Oh, did I do it wrong? Yeah, I had to do this. Ha ha ha, right? And then they combine it again, so they do this, and then they do 130. I'm like, what? So, but if we do it in the abacus way, right? We do it the abacus way. We have 76. We add 54. Can we add the 5? No. How do we add the 5? Do we know how to add the 5? We know. Plus the 5 is what? Plus 5 is equal to plus 10 minus the 5. So I'm going to plus the 10, 1, 0. No, no, I'm over here. Plus the 5, 1, 0. Plus the 10, 1, 0. Minus the 5. And then we need to add the 4. We're going to add the 4 here. When we add the 4, can we do it? No. Plus 4 is equal to plus the 10 minus 6. Plus the 10 minus the 6. So my final answer is 30. Yeah. Right? It's different when you write it out, and it's different when you have it like this. My first two children were sent to Montessori, and they learned. Yeah, yeah, that's really fantastic. The biggest thing is understanding, like, yeah. I mean, oh, that was the other thing, was like, we are told to write down checklists, right? Tasks and all this and that, write it out. But then we're forcing the kids to figure this out in their head. And I feel like it's a disservice. I don't know why. I don't know why. Yeah, I don't. Yeah, I don't know. So, but yeah, that was that there was I mean, this is a little overwhelming to see. Does it make sense? I guess, right? You know that this is 70, but then if we know here, we know that this is 70, right? 70. I don't know. To each their own, but I don't teach that way. I teach the abacus. And so it's not for everybody. I know that. So my second child has an IQ. Woo! I did a lot of mental math growing up because it was too much joy. Yeah, yeah, it is too much joy. And funny, I got the kids to do memorizing their multiplication because of the abacus, because they're like, it's too much to like keep adding it on the abacus, so they start memorizing certain numbers, right? So if they did like what, 9, I don't know, 6 plus 6 is 12, right? They would have to memorize that, and then they'd have to do 18, and then they do like 24. So 24. So I got them to do because on the abacus it's additive, cumulative, additive, addition, cumulative addition. And so yeah, my kids got annoyed when they write out the process. Yeah, my kids too, but I had to tell them, you have to follow the teacher. If the teacher wants you to write it out, you got to write it out. There's no way around it, because how are they going to know, right? How is the teacher going to know what they're thinking? But I don't know. I don't know. So even my kids know abacus. I told them, you still need to do what the teacher asks, because they want to make sure that you understand the way they're teaching. So it is what it is. My brain normally turned 67 to 80, and then I added 50. Oh, interesting. I was a stickler at home making them do it. Yeah, I wasn't too much. I wasn't too much of a tiger mom. I kind of let them do. But then that was the other thing is like I didn't know they my. I don't think my kids struggle with arithmetic because they knew abacus, and they would just use abacus as a double checking. I know I love how everybody works, and yeah, they work their very own. And it's interesting on how they all bring it together. But yeah, but see, that's the thing because you have a strong sense of numbers. Tropical paradise. If you do 76 into 80, and then you have 50. Yeah, yeah, cool. So that was double digit. I don't know if Striker is still here. All right, we're gonna continue on with adding and subtracting. Should we continue on, or what are we gonna do? I think I'm ready for another. Should we do a review? We can do a review. The review is how to read the abacus. And when we're looking, this is how we read the abacus. Here's a little worksheet. If you're looking for this worksheet, I have a service link at the bottom right here. There's a service link. And if you look at the service link, click on it. You can DM me and I will send you a link to the worksheets. Yeah. If you're looking for books, I have it in the TikTok shop. There is my TikTok shop over here. There's a button that says shop. There's 8 available. I do have books available. These are available. And if you don't like TikTok shop, I am here as well. My name is Lynette. Hello. I've been teaching abacus for about 20 years, and now I've been publishing books, and it's been good. I feel pretty good about it because I know abacus is really boring. Here is an example of an old abacus book. Actually, the abacus book that's out right now. This is not mine. This is an example one. And this is, I think, 60. Yeah, these are 60 questions. And they just keep doing it. It's a little mind numbing. So I do appreciate the work that they put into it, but I also appreciate mine is more creative. So, but yeah, if you're looking, I do have books available. And it's pretty easy. And does it confuse the kids when they go to mainstream school? It doesn't. We are a very neurospicy family. Cell biology. Oh, that's fantastic. Those are very big words, Sarah. That's like above my pay grade. I only know a little bit about math. Infinitum. That's funny. Yeah, bioinformatics. That's very interesting. I don't. Yeah, that's pretty cool. Oh, okay. So what are we doing? So here it is on the abacus. We have 0. This is 0. We have 1, and this is 2. After 2, thank you. I appreciate that. 2. This is 3. After 3, we have 4, and then we are going to go to 5. 5 looks like what? 5 will always be the top bead. The top bead is 5. And then we have 6. That's what 6 looks like. 5, 6. And then 7, 5, 6, 7. We have 8, 5, 6, 7, 8. This is 8. And then 9. 5, 6, 7, 8, 9. Well, what's after 9 is 10. That looks very familiar, doesn't it? We have 10. 1 and a 0. 1, 0. Then we do 11 and then 12. I wouldn't be here for 30 minutes if you weren't. Thank you. Thank you, Sarah. I appreciate that. A lot of people who stay a little bit long, they're like, why am I still here learning about, math in the middle of the night? And it's quite interesting on how people just kind of stick around. But I appreciate those that do and they have and comment, right? And if they don't understand, I enjoy the comments. I enjoy the questions about abacus. So, yeah, anything about arithmetic is really quite interesting to me. But I didn't go anything higher than that. Like I didn't go into algebra and trigonometry. I'm focusing on mainstream math. Um, I'm focusing on arithmetic specifically and filling the gaps that we have. This, I need more friends. That's so funny. It's hilarious because and it's so true. Like I just gotta keep showing up, and I was actually just thinking about continuing to work on my book, but I'm like, you know what? I kind of miss the interaction with people, and I wonder what people are out here. And I always have the greatest people joining and having conversations. This is fantastic. When I first started my lives, there was this one math professor. He's from England, and we were talking, and it was so funny. We were talking, and he's like, "You sold me on the abacus." And I was like, "Thank you. I appreciate that." And it was like hilarious. So, oh, book? Yeah, I'm on my 10th one. I have a whole curriculum that I want to do. And so after I finish the abacus curriculum, I'm going to section it off into specific grades. And then after I do the grades, we're going to do multiplication and we do division. And then after the division, I was also going to do abacus, introduction to abacus for adults. And so, like, I have a whole line of things, but the problem is I'm creating it and it takes time to create. So I'm on my 10th book. I have 10. I'm on nine. I have 9 books published, and I'm on my 10th one right now. So, trying to find activities and different ways of explaining certain things. Yeah, and it's just fun. But because my kids are a little bit older now, so I have a little bit more time. If I don't do this, then I'd be annoying my kids. So I choose to be a little bit more productive and try to, bring abacus to more mainstream. How old are my kids? My oldest one is 18 and he's graduating tomorrow. He's graduating tomorrow. And my middle one is 13 and he's graduating middle school. And my youngest is 18, 14, oh, 12. Yeah. My youngest one is 12 and he's in grade 6. And they'll be going, obviously one step. So, yeah, and they all learned the abacus, but they never went through my worksheets because I didn't make these for them. I made these for. I just made these because I was realized that we have a gap in the abacus world. A lot of the abacus schools and learning centers will start at kindergarten, but I want to get them to be preschool. Mine are Yeah, mine is all public school. Mine are so we're about the same age. 19, 17, and 10. Yeah, we're about the same age. Mine's a different gap. Yeah. Mine are all boys. I don't know about you. I was hoping for a girl, but that didn't happen. But yeah, these are my books. And yeah, I'm in the process of building more books. I want to try to keep going. I'll keep going till I get to I think I'm just going to keep going because I really do enjoy creating the books and then just kind of providing knowledge of abacus and making it more modern. So what I did was I was trying to modernize. I noticed that the activities now in school is very active. The math is very activity based. So what I was trying to do is I was trying to make it more activity focused. So here is the how to spin the wheel. Spinning the wheel just means that you take a paper clip and you do that. Yeah. Yeah, it's very rote. It's very rote. And so the reason why I did it this way was to try to get the kids to critically think why we're doing certain things. And I give them some questions that they don't have to do anything, but I also sprinkle in questions when they have to make it. So this is very specific on focusing on the add-in. So if we have 16, we want to do how do you take away the 3? So when we take away the 3, they have to go through the steps. Can they add the 5 or can they add the 10 or take away the 5 or take away the 10? So that was the one thing about that. It's a yeah, it's a I spend I'm sending my kids out of the real world and I like sending my kids out in the real world and learning hands-on. Yeah, a lot of learning these days is 90% abstract, if not more. That's very true. It is 95%. And a lot of and it's too bad. Um it is too bad because I think now we're going to the one spectrum of trying to be more abstract than anything. Even when the kids were younger, I knew that there was a lot of abstract strategies when the kids were 5, and I'm like, They don't even know their basic fundamental numbers, and you want them to try to critically abstract thinking, all these other things. I'm like, I don't see how that's even possible. When we're learning languages, we learn from somebody, right? When we're learning a language, we're learning from somebody. I don't understand why we don't do the same thing with math. Right? If I teach you 1 plus 1 is 2, right, then that's fine. But I can't say, here are these numbers, here is these random symbols, figure out your own way to how to add it. And I'm like, that doesn't make any sense. Give them something, like give them anything, give them something concrete to do. Then they can start building from it. You know what I mean? Like, there's no point of giving me the symbol 3 if I don't know what it even means. Oh, it makes me mad. It makes me mad. But it is what it is. And so that's what I'm trying to do. I'm trying to continue on. So if I build enough and be comfortable, be confident that I can bring this into the mainstream school, and then hopefully from there, the one thing is to also teach the children, teach the kids. I am. If I am saying, no, no. I've been on rants on the mainstream school many times. And it's just one of those things, like it amazes me. But you know what? It also depends if we have the time, right? Like, I don't blame the teachers because they don't have the time to learn other ways. I left the school 2 years ago for that reason. Yeah. But see, but they're so, teachers are so inundated with so much learning. I was trying to make it easy. So if I ever get to the point where I can actually create a professional development class and professional development curriculum, and it's just, here is here is a package for you, and they just need to implement it, right? They're overburdened with restrictions. Well, even with restrictions, like, the other thing I have to do is I have to start labeling, how does the common core relate to abacus? And then that's another thing that I have to also do. Like, I have to start labeling, like, we're learning like 0 to 9 or 0 to 10 or whatever. So, hello, 8144. Inclusion is definitely slows everything down. But not teaching everyone isn't fair. Yeah, but teachers are human, right? They're not robots. And so they are, it is what it is. I've had some really good teachers for my students, and I have some really not so good. But the kids learn any the kids learn how to adapt, and they move forward. You know what I mean? So it's not like completely just on the teachers. The kids also need to know what to do. So, and it's also, if the parents have the bandwidth to also guide them. I don't know, it's like a combination. But if the teachers want a specific way, then the kids need to abide by it. So, students are humans too. I did not succeed until I went to college. Yeah, I didn't succeed until maybe in my senior year in my college. That's when I understood how to study. And then ever since then, it was like, I couldn't cook. Uh, yeah. And that's the interesting thing, right? We had to pay my, yeah. And that's the interesting thing about it, right? Like, it's not just it's not a teacher's fault. It's also depending on the environment and the students as they come through. So it's a very fluid. And oh, another teacher, I was talking to a friend of mine, and he's a teacher, and he mentioned it the same way, like, teaching is an art form, but it all depends on the teacher. It all depends on the artist, right? And if they really enjoy it. And then I was talking to another person, how she wants to serve underserved children. And again, in her situation, she wants to be like, I'm going to give you an abacus, you take it to school. If the teacher has a problem with it, then the teacher needs to find another way to get the kids to learn. And I was like, that's pretty good. But I'm not from that. I'm from a different neighborhood or upbringing, or not upbringing, but a different neighborhood altogether. So yeah, for me, when we were coming in, I would always ask the teacher, is it okay to bring the abacus? You know what I mean? But I know it's about environment. And so she knows, and she was like, no, they need to bring. It's like, that's great, that's fantastic, I'm here to support you, but you have to, she, that's her realm, you know what I mean. And so it's very interesting on how to bring up, education is just so interesting. But I do hope that abacus is available to everybody. I do hope that it's available to, anybody and everybody. And I, provide the information. And she's looking for that, and I'm hoping that she will be successful. So let's see. Ah, thank you, Tropical Paradise, for the follow. Now I'm just rambling. All right. Okay. Ah, I insist in the sit-in classes before I registered. Learning the teaching style is important. It is very important, but it also depends on what we're trying to do with it. So, all right. So here we have making minus the 5. We do minus the 10. We do plus the 10. We can do, let's do a couple of questions of multiplication, and then we will sign off. Special. All right. Okay, so let's do a couple of questions of multiplication, and then I'm going to sign off. All right. So here is the question. Now, what we're going to do is we're going to do distributive property. When we do distributive property, this is what we do in distributive property, if you don't know. So now we're doing multiplication. The reason why is how we do it in abacus. Now, the question is why are we going to, what are we going to do? Well, we need to start with the number. What is our answer? Our answer, yes, thank you, user 141. I'm sorry, 8144. Yes. So we're going to start and count our digits. We're going to count 1, 2, 3. So we have 1, 2, 3. The first thing we're going to do is we're going to understand how to multiply. When we're multiplying, you're the one entertaining everyone with conversation topics. We're going to 8 times 9. 8 times 9. 8 times 9 is 72. When we add 72, we're going to add 70. We add the 2, right? And then what are we going to do? Oh, sorry, forgot. I forgot to show my arrows. So then what we do is we got to do 8 times 3. 8 times 3 is what? 8 times 3 is 24. So I add my 2 and I add my 4. So my final answer is 744. Yes, thank you. Thank you, Apple user. 744. I see you. It's been a little bit, hasn't it? All right. So what's the next one? Let's do another one. We have 853. Times that by 7. So when we're doing it, right, we're going to count again. We're going to count our digits. What does that mean? The reason why is we want to know where are we going to put our answer. 1, 2, 3, 4. How do I know? 1, 2, 3, 4. So in mainstream, we do 7 times 800. But in abacus world, we don't need to do that. In abacus world, we just need to do our multiplication fact. 8 times 7 is what? 8 times 7 is 56, right? So we had our 5 and then we had our 6. Notice because I put it on my abacus, I don't need to say 5,600. I just need to figure this out. So when we do this, right, 7 times 5 is equal to 35. Add my 30, add my 5. And then what do? 7 times 3. 7 times 3 is equal to 21. I add my 2, and then I have my 1. So what's my final answer? That's why I remember multiplication table. Yes, 5,971. That's my answer. Yep. Thank you, user 841. 814. Yes. So what we're going to do, right? And if you notice, this is what we call simple. That means there's no formula involved. How are we doing? We can do another one. I curated the questions, you Apple user. Another one. Okay, so here, let's do this one. We're going to count our abacus. 1, 2, 3, 4. We have 4. We do 1, 2, 3, 4. And then what are we going to do? We do 5 times 4. 5 times 2 is 10. 5 times 2 is 10. Add 1, add 0. 5 times 4 is 20. Add 2, add 0. And then what? We're done with our 5. Now what? We got to count again. 1, 2, 3. We count 1, 2, 3. 8 times 4, 8 times 2 is 16, right? Add 16. Add 1, add 6. I'm over here. 8 times 4 is 32. 32 is what? Plus 3 plus 2. So my final answer is, what's my final answer? I am on the east. I am on the west coast. Why does the ones on the abacus start from the 2 or the because I have a ones indicator. This is my label. If you notice that there's a dot right here, there's a dot right here. This dot tells me that this is my ones place. Because this is my ones place, then I have my ones, my tens, hundred, thousands, 10,000. You could choose this, and then that would be your ones place. So it'd be your ones over here. Ones, tens, but then you have no more room for hundreds. So that's why I start here, because I have my indicator, my ones indicator. I love this more complex application to understand the efficiency of abacus. But absolutely knew you were West Coast because it's 3 a.m. on the East Coast. Yeah. Yeah, not a problem, Bree. Thank you so much for the question. But that makes sense. So yeah, there's a lot of people that stay up till 3 in the morning, and I don't know why. You guys are all crazy to be learning in the middle of the night math. So we'll do one more and then I'm going to sign off. Yeah? We'll do one more. So here we have it again. 7. I never happened until I turned 40. You're young. All right. So count the numbers. 1, 2, 3, 4. 1, 2, 3, 4. And then what do we do? 5 times 7 is what? 5 times 7 is 35. We add 30, we add 5. And then 5 times 4 is 20. Add 20, add 0. And then we count again. 1, 2, 3. Why? Because we're done with our 5. We have no more 5 to do, right? So we go back to here. 1, 2, 3. 1, 2, 3. We're over here. 7 times 4. 7 times 4 is 28. Add 20, add 8. And then we do our final one, 4 times 4. 4 times 4 is 16. I add 1, I add 6. So my final answer is 3,996. I just joined. Oh, hey, Britta. I'm so late. Muffled of the night early here. Yeah. So does this make sense why this is 3,996? Well, how do I know this is 3,000? Because every column has a place value. So this is my 3. This is 3,000. 1, 2, 3. 3,000. This is hundreds. This is why it's 9. 5, 6, 7, 8, 9. And then what? 5, 9. And then this is 9 again. 5, 6, 7, 8, 9. And then what? Now we have 6. 5, 6. And this is my ones. I have my ones, my tens, my hundreds, my thousands, my 10,000s. Hello, Kyla. Excuse me. Good. Yeah, thank you for staying on. I appreciate that. Yes. The top bead will always be 5 no matter what. Thank you, Amanda. Yes. So when we count, this is 5. When we do 6, we have this. This is 6. So if I did 1 plus 5, right? 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 5 is 9. Exactly. Thank you. Yes, exactly. All the top bead, all the blue bead is counted as 5. But if you're colorblind, we can change this. There's no excuse. So we could do it again. So if you notice, I'm going to choose this dot as my ones indicator, my label of ones. Then because I have this as ones, I know the next indicator is the thousands. So if I choose this one as my ones, then I have my thousands over here. Millions, billions, and then trillions. Yeah. Oh. Yes. This is called a soroban. I'm sorry, Kayla. Yes. So the top bead will always be a 5 no matter what. And then if you're interested in abacus referrals, abacus reference sheets, I have these reference sheets for free if you want it. These reference sheets. There's a link in the bottom that says Service Plus. You can send me a DM and I can send you a link to sign up for the worksheets. The worksheet. It's just a worksheet on how the abacus looks. But yeah, if you're looking for workbooks, I have it in my TikTok shop. If you're looking for other workbooks, I do available here. Hi, my name is Lynette. I've been an abacus teacher for 20 years, and I am all things about abacus. Hey, Ghosty! I'm trying to get the kids younger, like preschool. Thank you, Kyla. Preschool age, and then I do have a few adults that are wanting to learn, but I also but in the beginning I was focusing on the young kids, but now as I go through, I'm starting to realize that I need to provide abacus to older people, unless others prefer. I'm sorry, others prefer what? I'm sorry, Britta. I don't know what happened. I think a comment got filtered. What was your comment, Britta? So, okay. Is abacus used for people that may struggle with math or advanced individuals? Um, if you ever see those kids that do this, the gang signs, they're using abacus. In America, it's a little sad, but abacus is used for special ed. But it's not just for special ed, unless my kids are special ed, but they're not. um, you are the kind of contact readers who deserve roses. Oh, thank you. Don't feel obligated. I don't know what you're saying, Britta. So abacus, so that was the other thing is abacus eh, is it for advanced, it develops into advanced math users, if that makes sense. So what we're doing is just a basic understanding on how to add and subtract, and the abacus really helps that. I'm missing a comment, Britta. I don't feel obligated. I don't know what you're talking about, Britta. What's going on? I don't see a question. Okay. So, does that make sense, Kayla? Um so yeah. I'm trying to get to a point where abacus becomes just part of mainstream. The reason why, because uh, I really do believe that abacus is very beneficial for everybody and anybody, and it's not just for Asians. It's not meant. It was meant to be a tool, and this is a tool for math, and it's very interesting on how abacus makes everything just so much more simple, so much more simplified. You know what I mean? And easy. It gives you manageable chunks, which is very interesting. So if you look, you can supertize. When we do numbers, right? Here, when we do numbers like this number, we do dots. I don't know if you remember this in school. We do dots, and we're like, okay, if we do 5 plus 3, we have to count 1, 2, 3, 4, 5, 6, 7, 8. Because why? The human eye can't see more than five. But on the abacus, we're easy to see that this is eight. Because remember that 5, 6, 7, 8 together, this is now eight. So we can see instantly that this is 9. So it's easy to supertize. Supertizing just means that you could see the number and you know what it is. So if I do this, I know this is 10. How do I know? Because this is 1 and this is 0. The children that use abacus, do they use a tool and test? They can if they want to. Is it restricted? It should not be restricted. The reason why is because I know calculators are no longer allowed in SATs or something like that, in some sort of math class or math test. I know, but I believe you could still use the abacus because an abacus is not really a calculator. An abacus just tracks your numbers. The calculation still happens in your head, if that makes sense. So when I'm looking, my question is always like, can I do it? Yes, I can. Then I'll just do it. But as we go through and we do like multiplication, division, you'll see that calculation actually happens in your head. You're just moving the beads to help you keep track of it all. Um, Britta, am I still missing a comment? I don't know what we're talking about. I missed the whole lesson. Oh, I see. Oh, Dom. Thank you, Dom. Okay, the whole lesson. Okay. That was my other question. Have you seen kids more reliable on to be in front of them? No. The kids are not reliable on front of them because they use it often enough that they can actually visualize it in their heads. So, so Britta, let's go back. Hey, Panda. We do 1 plus 1. Did that make sense? So Panda said 1 plus 1. That's what 1 plus 1 is. Yeah. And then we have 2, 3. This is 3, and then this is 4. After 4, we have 5. Yeah. Okay. So yeah, going back to the kids being reliable on it because it has to be in front of them. Well, no, because if you do it enough times, you can actually see the beads in your mind, if that makes sense, right? So yeah, not a problem, Kyla. Jose, 7 times 5. You have to know that in your head. You have to know the multiplication in your head. We can do 2 digit, like 53 times 7 or something. But we can't do 5 times 7. He's so silly. Yeah. Yeah, he's been with me for a while too. He just likes to play. Just joshing you. Okay, 27. All right. All right. 27 times 4. Let's do it. I've never heard about it tonight. That's very cool. Yeah, please. You play. Stop playing. Okay, 27 times that by 4. So we're going to count our abacus. We're going to count everything. 1, 2, 3. 1, 2, 3. 4 times 8 is no. 2. 4 times 2 is 8. 8 is a single digit. I go back 1 comma, add the 8. 4 times 7. 4 times 7 is 28. Guess what? We don't have enough beads to add 2. Add the 8. Add the 2. To add the 2, we know plus the 10 minus 8. Plus the 10 minus the 8. And then we don't forget, we have to add another 8. and we add the 8. So my final answer is 108. I hope you have a glorious day. Things are glinting streaming wise. Thank you, Britta. Thank you, Britta. Thank you, Panda. 10 plus the 10 minus the 8. Britta, I hope that made sense. Oh, Alo. Alo. What's wrong? Don't cry. So this is a plus 10 formula. This plus 10 formula is what we were working on before. Ah, did you go to school for mathematics? No, I did not. I went to school for linguistics. I learned abacus after college. And it was only because my dad wanted to open up a learning center and he wanted to build out his retirement. And he forced my brother and I to learn math or abacus. And I'm like, this is crazy. Why are we learning abacus? What for? There's no point. And then as I learned it, I'm like, oh my God, this is the greatest thing next to sliced bread. And I'm like, all my kids are going to learn it. So I learned how to do the abacus. And then from there, I started building out my workbooks and worksheets. Yep. And so there's an actual strategy. There's an actual framework of understanding and going through the abacus curriculum because there's a methodology. There's a framework, and so we don't just give you a hodgepodge of questions. We actually give you specific questions for the specific concept. I do like sliced bread. Yes, sliced bread is really good and as good as Betty White. I don't know if you know who Betty White is. She's passed away, but she was really good too. Okay, so it is late. I do appreciate everybody joining. Thank you so much for the comments and the questions. Thank you, Kyla, for continuing to learn. I do appreciate that. I hope it was okay for you. And thank you again. Let me know if you have any more questions. I am going to sign off. Thank you, guys. If you're looking for books, I have it in my workshop, in my TikTok shop. If you're looking for other ways, I have another way. And hi, my name is Lynette. Thank you, Fatima. Thank you so much for joining me. Good night, Tropical Paradise. Thank you. No, thank you guys. See you all in the future. Yes, see you all in my next live. Again, if you're looking for more abacus books, my name is Lynette. I am here to help to teach more about abacus, and I hope to live vicariously through all of you guys and relearn how to add, subtract, multiply, and divide. Okay, so have a good night, everybody. Sleep well. Thank you. You too. Sleep well, and have a good night. Bye.